The really cool thing about an absolute encoder is you don't have to do homing after power up or reset. You've got an absolute encoder. You're done. The thing that's really not cool about it is you got to calibrate your system. If your motor shaft slips or if your belt comes loose, the mechanical system falls apart and you have to put it back together again, you're going to have to calibrate where the zero position is in your system. So what I have here today is a brushless rotary motor with an absolute multi-turn encoder. The battery holds the absolute multi-turn position. The encoder does give you a single turn of absolute, but this is a linear stage, a Thomson microstage, so it's several turns of absolute information. I've got the serial connector hooked up with the B&B USB to serial adapter so I can calibrate it over the serial port. I've got the Stowe bypass jumpers in, 24-volt mean well power supply. The motor's hooked up and the feedback's hooked up, and it's all been tuned, and the mechanical system's been tested. We can make moves. I've got the AC power hooked up. So what I'm going to do is I'm going to move my stage to the position that I want to be zero. So I've moved it down to this end here. It's close to the mechanical hard stop. It's before a limit switch, and maybe it's near a home switch. I've got my motor shaft that I have to connect, and right now, on power up or reset, my absolute encoder tells me the position that it's in. It's probably not zero. Hey, and would you look at that? It's not zero. It's like 46 billion counts. So, one way to calibrate this system is to move the linear motor to the position I want to be zero, and then before I attach the motor calibrated, I move the motor shaft to zero. So how I've done this in many systems is just to use the CME2 scope. I put in an absolute move to the zero position with some trajectory, and I start the move. Well, there I go. Now I just have to wait. Okay, we're finally done rotating. I can't tell you exactly how long that took, but I got another cup of coffee and used the bathroom. So now we can see that we're in the zero position, and what I can do on the mechanical system is I can hook up the motor. And when this encoder powers up, it's going to give us its absolute position, and it's going to say the zero position. So everything is with respect to where I connected the motor. Now sometimes we don't want to do this. We want to do a different homing method. So we'll take a look at the different homing methods. Under CME2 Help, all documents are a bunch of documents. One is the CME2 User Guide, the Parameter Dictionary, and the CANopen Programmer's Guide. So we're going to take a look at these three documents. The CME2 User Guide talks about a calibrate button. What does that do? Well, it runs a normal homing sequence, and then it saves an offset value to flash, and then it changes the homing method to absolute immediate home. So we're going to see how to do that. We've also got the Parameter Dictionary, which has the homing method configuration parameter 0xC2. And we can see one of the homing methods is 15, immediate home. And that also cross-references to the CANopen Programmer's Guide. So if I'm a software engineer, I can use this object and a home offset, and away we go. What this documentation doesn't tell you is exactly how to get the offset value. We got to figure that out. So let's take a look at what we got now. On the basic setup screen, we can see we have not run a homing routine. I've moved my encoder to a position I want to be zero. Well, it's hard to get to zero by hand, and then after I attach it mechanically, it's going to be pretty close, but maybe I want something more accurate. So what we're going to do is we're going to go look at the homing methods and pick one that we like. For example, if this was a hard stop that I went to, I'd just run a normal home to the negative limit, hard stop, and then I'd back out maybe a millimeter or so, depending on how many counts per millimeter there are. And that's one homing method. I can execute the homing method, I can save the homing method. So normally on power up or reset, the home is not referenced. So the absolute encoder will tell us its absolute position on power up or reset. And right now it says that it's at minus 67 degrees. Now if I rotate the shaft several times, I'm going to have a much larger multi-turn absolute position on power up or reset. This is the position that the encoder tells us on power up or reset. And if that's the position I want to be 0, say it's connected to my mechanical system, and my mechanical system is in the position I want to be 0, well then I can use the absolute immediate home. So let's take a look at the absolute immediate home and see how that works. So from the list, absolute immediate home, and I need to come up with an offset. Well, if I'm in a position I want to be 0 and the encoder is telling us I'm not in that position, I need to subtract a number from it. 1,227,807. So this is the position I want to be 0. The encoder is telling me 227,807. So I subtract 227,807, and that will be 0. So I'm going to initiate the homing routine, and I'm going to save it to the drive's flash. So now on power up or reset, I will be referenced to 0. So if I reset the drive, even though the encoder is going to tell me 200,000 counts, I'll have subtracted minus 200,000 counts from that, and I'll be referenced and I'll be in the 0 position. Now let's suppose the mechanical system comes loose. I have to do something all over again. I'm going to have to calibrate again. So I'm going to turn off absolute immediate home. So we're going to do something like set current position to 0, set the offset to 0. I can execute that homing if I want, but I have to save it to flash. That way when I power up or reset, the homing routine will not have run, and the encoder will tell us its absolute position from the time that it powered up. So we notice that the encoder is no longer in the 0 position, and it has not referenced home yet. The homing routine has not been run. So the absolute encoder tells us its position on power up or reset. It's like 200,000 counts. So I move the motor shaft to the position I want to move it to. I connect the mechanical system. I move the mechanical system to the position I want to reference to 0, and I come up with an offset value. And again, I don't have to set this position as 0. I could use something like home to a hard stop. Come out of the offset. Maybe go negative hard stop and come out some positive distance. I'd run that routine. The actual position that the encoder will tell me that it's in on power up or reset is going to be something other than 0. And that's the value that I'm interested in. So after running a normal homing routine and locating the position you want to be 0, this is how you get your calibration value. So I'll change the homing routine, and I'll put in the offset value to 39755. Save that to flash. I'll reset the drive, and it should run the absolute immediate home. So I'm referenced, and my position is 0, assuming that's the calibration value we came up with. Okay, so let's look at this from a different perspective. Let's say we're doing this with can open, and we're going to use a normal homing method first to get the calibration value, and then we'll do absolute immediate home. So we can see from the CanOpen Programmer's Guide, there are many homing methods. We have to pick one. So for example, we could manually move down to some position and use set current position as home. And then we'll have to figure out what the offset value is going to be. And then we change the homing method to absolute immediate home. And then we use that offset value, or maybe the negative of that offset value. So here I've set the current position as home method, and I've moved the linear actuator down to the hard stop, but I want it to back off in the positive direction some number of counts. I'm going to save this to the drive's flash, and then I'm going to reset the drive. So before the homing routine is run, we have not been referenced yet, and our encoder's given us a really big number. So what we do is we take a look at the homing method that we've picked, and we can see the actual position is what the encoder gives us on a power up or reset before the homing method is run. That could be the offset value, take the negative of that, but I want to give it an offset of 10,000. So I'm going to initiate the homing routine, and I'm going to see the new homing adjustment value. And that's the negative number that I'm going to use for the offset, minus 259,516. So that's 10,000 counts off the position I used from the homing method, set current position at home, at the end of travel. So this parameter, homing adjustment, after you run a homing method, you can read this parameter from the drive. So 0xb2 is the ASCII parameter, or can object 2353. I can read that value, and then I can use the negative of that in my absolute immediate home algorithm. So that's the new value. I save that to flash. I run the homing method. I can even reset the drive. And on power up or reset, that homing method will be run. So here I am, close to the home position. So homing method calibrated, and then homing method run. Again, if something happens in the system, like the motor becomes disconnected and somebody turns the shaft, or the shaft slips, or the mechanical assembly slips, we may need to recalibrate. So there should be an algorithm in your software if you're using CanOpen, or if you're doing it over the serial interface, for calibrating the system. Of course, you can do this from CME2. There's a calibrate button. And, we would start off with the homing method we want to run. And you press calibrate, and it runs the homing method. It comes up with a homing adjustment, takes the negative of that, and then switches the homing method to absolute immediate home, just like we did manually. So there's a calibrate. It's trying to help us. There's a description in the CME2 User's Guide, but again, it's not much of a description. It just tells us what it's doing. It's doing the same thing that we could do manually. So absolute encoders are wonderful. They give us the absolute position on power up. We don't even have to home. It's easy. Unless we lose our position, and then we got to figure out how to recalibrate the system. But that's also easy, because we can do a normal homing method, come up with a homing adjustment, use the negative of that, and you select the absolute immediate home after power up or reset. We don't even need to move to the absolute position. We know where it is. So on power up or reset with absolute immediate home, you're done homing. We know where the 0 position is because it's been calibrated. Thank you, and enjoy your Absolute Encoder.